So this is a simple class with some properties for our domain entity, book. Nothing too fancy, but it will be the foundation of this new feature that we are going to develop. So the properties. So these are the properties that we are going to start with. Next, we need to persist our data. So for simplicity and to avoid having to set up a full database for now, we'll use EF-Core's in-memory provider. So it's perfect for testing and getting things up and running quickly. Let's create a folder called infrastructure. And then inside of this infrastructure, we're going to create another folder called data. Then we're going to create our DB context here. So let me rename this, rename file. And then inside of this, we'll create our, DB context, as I said, using the in-memory provider. So it's going to be called bookstore DB context. And it has one DB set of type book, which we need to import. And then the next step would be to register this context in our program.cs. Again, as I told you in the previous episode, we're going to add our registrations inside of this service collection extensions. So I'm going to add this registration here for our DB context, and as you can see, the name of our in-memory database is going to be bookstore DB. So now that we have set up our DB context and we have our registration in place, we need to create a feature slice, and that is going to be called create book. So we're going to create our very first vertical slice. This is where all of the pieces of our feature, like the command, the handler, and the response, will live. So as I told you in episode number 1, we're going to organize our project by features. We're going to have a folder called features, and inside of that we're going to have a folder called book. And then here we're going to create another folder called create book. So this structure, as I told you already, makes it crystal clear where to find the logic for creating a book. First, let's create the command or the request type, because we're using a mediator. The command is the message that tells our application to do something. It's the request object that will come from our API. So we'll define it as a record inside of the features, books, create book folder. So I'm going to go ahead and add class code file called create book command, and I'm going to, as I told you, implement this as a record. Notice how clean this is. A record is perfect here because it's an immutable message that contains all the data needed to create a book. The I request interface coming from the mediator part is also very important. This kind of tells mediator that this command expects a create book response back, but this type hasn't been created yet. We're going to create that in a minute. So yeah, this is the DTO. This is the record. Now we are going to create our response DTO as well. So this will be the object that our handler will return, and we'll create it as a class. So I'm going to create it here in the same code file, and then I'm going to move it into a separate code file. And then I am going to talk about why it is recommended to go with records for commands and go with classes with getters and setters for responses. So I'm going to move this to its separate code file. This is the command and the response. So the handler is the next step, creating the handler. The handler is like the workhouse of our slide. So it listens for the create book command, and it contains the logic to actually process that command. So we'll create it again inside of the create book folder, and we're going to have a code file for it called create book handler. So I'm going to create the class here, and then I'm going to move it to another code file. The handler will have a direct dependency on the constructor, on the context, on our DB context. And then of course, for the handle part, because this is a create book handler, we're going to create a simple book based on the values that we are going to create in our handle method based on the request object that we're going to receive in the handle method, and then we're going to call the save changes on our context, and then we're going to return a create book response. So this is the task, the handle method. Let's create a book object, a book entity object based on our request parameter, and then let's add it to our context. And finally, after saving changes, we're going to return a book response, a create book response. This is the way we implement the handler. And of course, we need to change this to title, and this one is going to be author. And then here, yes, I need to use entities, domain entities book. So this is the handler. Again, as I said, this is where the magic actually happens. We are injecting a DB context. We're creating a book entity from the commands data in our handle method. We're going to add it to the database, saving the changes, and finally map the result back to our create book response. Now we need a way to kick off this whole process, right? So our API controller will act as our entry point. We'll create a new books controller and inject iMediator into it. So I'm going to create this controller. I'm going to call it, it's going to be a web API controller. I'm going to call this books controller. And then inside of this books controller, first, as I told you, we're going to have a dependency on iMediator because we need to be able to send commands. So in the constructor, we're going to inject mediator, which is of course going to get resolved, and then the endpoints for creating a book, which is going to return a create book response. So again, this is the beauty of using mediator, right? Our controller doesn't know a thing about the handler or the database logic. It just receives the command. As you can see here, it just receives the command, and then it kind of sends it to our, using our mediator, it's going to be sent to our handler. Mediator then takes care of routing the command to the correct handler. This keeps our controller incredibly thin and focused. Now, before we test these, I want to talk about let me do something. Let me first move this to a separate code file. So move type to a separate code file. And I want to talk about why we decided to implement our command as a record and our, response DTO as a class. Let me again now talk about this. This is, about a design choice that I have made. I have decided to, use a record for implementing a command, and of course a class for implementing a response DTO. Commands or queries are immutable messages, so they represent a single intention, like create a book with this data. By making them records, we get a few cool things for free. First off, you get value-based equality, so two commands with the same data are considered equal. Then you get a super concise syntax, as you can see here. And most importantly, they are naturally immutable, which is ideal for messages being passed around. Why the response is often a class then? You might be wondering again why we use the class for our create book response. I'm talking about this one, by the way. So responses are typically just DTOs, data transfer objects, that are sent back from our API. Many developers default to a class for a few reasons. Historically, for example, serialization libraries had better support for classes with setters. Responses are often mutable containers, especially when using object mapping libraries like AutoMapper to fill them, with data after construction. And honestly, sometimes it's just convention. Commands are records, DTOs are classes. Could the response be a record instead? Absolutely yes. You could have defined the response as a record, but again, as I said, even though this works perfectly fine with modern frameworks, responses are still immutable when implemented as records, and serialization works like a charm. Many teams actually prefer this approach to implement responses as records in a vertical slice setup where everything is designed to be immutable. So with that out of the way, I want to add a test request to my HTTP file and test things out, right, to this file. So we're going to test the endpoint in our controller to see if everything is wired up correctly. So I'm going to send, let me do something. Let me go ahead and add my request here for creating a book. The book is going to be Clean Architecture by Robert Martin. And I'm going to send this request, by the way, to book API books. And I don't need this one. And what I want to do is to mention that this comes from episode number 2. And let me go ahead, run this, and see what happens. So here, I'm going to save everything. I'm going to call .NET Run. I need to go to the project folder and then use .NET Run. Now, if I send this request, I am going to create, a book using my in-memory data provider, and I'm going to receive this, response DTO from my controller. So this works, right? This works like a charm. So we've just created our first vertical slice. Now let's talk about what we've achieved here. We've successfully built a vertical slice that groups all of the files for a single feature together. We've used Mediator to decouple our request and response handling from the API controller, of course. We've set up an in-memory database for now using EF Core. So this allows for quicker and for quick and easy data persistence for now. We're going to change that in the future. And we've got a clean separation of concerns. So our API just sends a command and the handler does the heavy lifting. And that's it for episode number 2. Again, join me in the next one where we'll continue to build on this project. I'll see you there.